They enter the event on this. Here we have the find target test. You can see we've got them entering the event on age 5. So if we should see our first particle probably striking our target around frame 35. As they come in on frame 5, where their age is then set to 0, and then they're allowed to travel on for another 30 frames before they actually have to reach their target. So the first particle should actually reach its target on frame 35. So up they go flying into the air. They fly up and they come down, and then you can see, bang, frame 34. It's not perfect, but it's pretty much perfect. You can see, there we go, they've actually reached their target by the frame that we've defined for them. So that's pretty cool. As you can see, you can actually define how they reach their target based on an absolute time, which is very, very useful. The next option is particle age, and in this case the particle age is actually 5 frames out compared to the event age. So now we'll find that our particles will actually fly up into the air, fly down, and strike the target on frame 30. Or again, as you can see, they strike it 1 frame before. That's probably because we've actually got a start frame of 0. So actually 29 is actually 30 frames onwards. So they actually hit their target bang on. They actually hit it 30 frames later, they strike their target. The last option is absolute time, and that's based on the actual frame that we have here. So our particles fly up into the air, they fly around, and then they come down, and you can see they strike our target on frame 29. So again, we've got an absolute value. So to make this a little bit more obvious, let's run through these again. I'll set this up to be an age of 20. Actually, let's just make it 10, otherwise the particles get too far into the air before they actually start trying to find a target. And then we've got a time value of 30 here. So if we use an event duration, that means we've got 10 plus 30 is 40. So they should actually reach their target on frame 39. There you go, it's reached its target. Then if we change it to particle age, we should be reaching our target on frame 29. Actually, we should be reaching our target, yeah, on frame 29. So there we go, they strike their target. And if we change it to absolute age, we should be reaching again on 29. There we go. So that's all working great. The next two parameters are parameters that we actually define the time with. You can see that in this example I've used a value of 30. And the variation works as it does in many parameters like the time value, where it's a positive and a negative modifier to that value. So if I used a variation of 10, that would mean that our particles could reach their target anywhere from frame 20 to frame 40. If I used a variation of 30, they could reach the target anywhere from frame 0 to 60. Obviously that would be a bit of a strange result, because that would basically allow our targets absolutely no time to get to their target. So that would obviously cause strange results, something that you probably wouldn't want in an actual real flow. Then we have subframe sampling, and this usual tick box, which we've had in so many other operators, is here to ensure that the timing values are applied to our particles on a subframe basis. If earlier on in your flow you've actually got your particles being birthed on a subframe basis, you probably want your find target test to actually be based on subframe values as well. Next we have use docking speed. As you can see, it's a tick box which is on by default, and this tick box enables the docking speed behavior, which in other words the particles will attempt to match the speed defined by the speed value, which you can see here, as they meet their target. So they'll actually try and be traveling at a speed of 10 when they meet their target. So you've got a lot of control there. You can actually define exactly how fast the particles are traveling when they reach their target. Again, we've got a variation value. Again, it's a positive and negative modifier. Okay, so that's the options there. Now we've got the last option, which is no control, and this effectively turns off the particle guidance element of this test, but of course still leaves the target proximity element intact. So if you don't want any of this functionality of the find target test to actually be active, just go up to no control and turn it off, and from then on it won't actually try and modify the path and the trajectory of your particles to try and make them meet their targets. It'll purely test to see if they actually reach the proximity of the target.